Hello students, I'm Dr. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now look at the question. Which of the following structure shows the exact protonation site in the product? Means this molecule and it reacts with H plus acid. So where the protonation will take place. And actually student, if you look at the options, 4 options are actually 4 possibilities where protonation possible. Now in order to get the exact protonation site, you need to understand which site protonation results maximum stability. That thing we need to find out. So if you look at these 4 options, which one is maximum stable and why? Whether if you look at protonation here, you can say, sir, one canonical form possible by the conjugation with this oxygen lone pair. And by the way, you may think that after this delocalization, oxygen is carrying positive charge. Is it really stable, student? It is comparatively stable. Why? Because this is a carbocation. Carbocation means 6 electron species, incomplete octet. Whereas if the positive charge remains on oxygen, it could enhance the stability. Why? Because both of these carbon and oxygen, they are 8 electron species. Now you can say, sir, oxygen is carrying positive charge. Being an electronegative atom, is it really stable? Okay, to some extent stable. Now next option, if the protonation happens here, then by the way, it doesn't have any special kind of stability. By the way, you can say, sir, hyperconjugation of these two hydrogen possible. I agree, possible, but that stability is lesser compared to resonance. So that's why I've ignored. Similar kind of stability you may expect from here also, but I'll not go. However, there is actually an electron withdrawing group, carbonyl, adjacent to this positive charge. So it will reduce the stability of this positive charge. So it is gone. A is comparatively more stable than B. Now if you look at option C, yes, protonation possible on this carbonyl oxygen also, because this carbonyl oxygen has 2 lone pairs, so one of them could be protonated. Now if you look at here, this protonation, what is the stability? Stability is that there are many canonical forms possible. I am drawing the most important one. So it means that this lone pair will come in conjugation and these will open up. So what it will result, a 6-member ring. By the way, here also similar, like the ring oxygen is carrying positive charge and the logic is same because of stabilization. Now this is, so this molecule is very unique. Why, student? If you look at this molecule is aromatic. Why it is aromatic? Because if you look at 2 to 4 plus 2 6, so 6 pi electrons are present and they are in conjugation. So according to Huckel rule, this is aromatic. Although you may say, sir, positive charge is there on oxygen. Yes, I agree that positive charge is there on oxygen and it may cause some unstabilization, but the stabilization obtained because of aromaticity is significantly higher. So these will be the very important option, means it is more stable compared to option A. Now if you look at option D, by the way, direct protonation on this oxygen, yes, I agree, possible, but remember, student, is the lone pair really available on oxygen? Because if you look at the neutral molecule, in the neutral molecule also such kind of resonance possible. So obviously this will result less electron density on this oxygen. If the electron density is less on this oxygen, obviously it is less basic, so it is less favorable to have protonation on these oxygen atoms, student, but more favorable on these oxygen because the final product is aromatic, and aromatic means stable. Okay, so the protonation will happen on this oxygen, means option C is the right product or right protonation site in this reaction. Now if you get this question, how could you get the right answer? Less than 30 seconds. For that purpose, you need to understand that, okay, first of all, this resonance increases electron density here, point number 1, and because of this resonance as well as protonation, these ring may get to some extent stability because of aromaticity. So obviously this is the right answer. By the way, you have to do little practice in order to solve such kind of question very early. So in conclusion, what you have learned, that protonation takes place on that site which is most electron rich in the molecule, and obviously the carbocation which is produced because of protonation should be stabilized by resonance. And in case of aromaticity, the resonance stabilization is very high. And remember the third point, being an electronegative atom, oxygen prefers not to have positive charge on itself. However, the aromaticity or stability may reduce the destabilization introduces because of carrying positive charge on electronegative atom like oxygen. So this is the overall learning for today's class. So thanks for watching. See you in my next video. Bye bye.